So today what we want to talk about is inverse sines. Now this is where you can see this whole thing arc. The whole idea about the arc comes from the unit circle, okay? So it says in degrees, but I really want to talk about A in terms of radians first, okay? So if you look at the unit circle and you find -1/2, so I'll draw a little picture over here so you can see it on the unit circle. So you find -1/2 for sine, sine's the y value. So you find -1/2 right here on the unit circle, okay? Now, the angle, so you do the angle is also in radians equal to the arc, and that's why they do the arc. So if you look at it, it's really going to be pi 6. So you can say, well, the answer is pi 6. So two things. One, in radians, the angle and the arc length are the same. That's the whole thing about radians. That's why we learn radians, is because we make sure the angle and the arc length are connected. If it's in terms of degrees, that's not true. Degrees are not going to be the length of the arc. But in terms of radians, so we get pi 6. Another way to look at this is you could write a sine inverse of -1/2. If it's sine inverse, then you're really looking for the angle. Well, the angle is pi 6, okay? That's why we use the term arc, because the arc, what is the length of the arc? It's pi 6, which is the same thing as the angle, okay? Now, if you do it in terms of degrees, it's a little bit different. We can say, okay, if it's in terms of degrees, then we'd say, well, the angle theta is equal to just a -30 degrees or 30 degrees, okay? We'll go -30 degrees now because it's a rotation. Okay, I don't want to confuse you. The word arc really does mean what's the arc length. The reason we learned radians is because we learned that the arc length and the angle are the same thing. That is what radians do. They connect us from the angle to the arc length, okay? But now if you're talking about degrees, then you need the angles in terms of degrees, dumb degrees. So if we go to the unit circle, -1/2 for a y value, it would just be a -30 degrees. What's the closest route to get it? In fact, you can use your calculator in terms of degrees, and you go sine inverse of -1/2, and you'll get a -30 degree angle, okay? Now, secant. Secant is not on your calculator at all. So what we're going to do is ask ourselves, how does this work? Well, if we think about secant, if we're looking at inverse, secant inverse, you're looking for an angle, okay? When you see this little symbol here, you're looking for an angle, all right? So let me rewrite the question. Let's say secant of -2, it has to equal some angle. That's what we're really trying to say. Secant of -2 is equal to some angle. So how do we figure that out? Well, let's rewrite it. So if I take it as secant of an angle equals -2, all right? You don't have secant on your calculator, but secant's the same thing as 1 over cosine. Secant is not on your calculator, nor is it on the unit circle, but we changed it to cosine. So let's go 1 over cosine of some angle equals -2. Now I'm getting somewhere, okay? Now I'm getting somewhere because I can do like my little flippy flop, because sine, cosine, and tangent, all three of those are on my calculator, or all three of those are on the circle, okay? So change everything to sines, cosine, and tangent. I just did, okay? We're going to flip them both. Rewrite it to cosine of theta equals -1/2, and that can be found on the unit circle in terms of degrees. -1/2 for the x value is at 120 degrees, okay? See 120 degrees? So my angle theta is going to be 120 degrees. Okay, that's it. That's not that bad. But again, you need to change everything into sines, cosines, and tangents to do it, okay? C, same thing. Cotangent is not on your calculator. It's not even on the unit circle, but if we can change it to tangent, we can do it. So let's rewrite the problem. So we're really looking for an angle, right? We're looking for an angle. So let's write as cotangent of some angle equals the square root of 3, okay? Cotangent's not on the unit circle, but tangent will be. So I've learned that cotangent is the same thing as 1 over tangent. So I've got 1 over tangent of an angle is equal to the square root of 3. We'll do the same thing. Flip it around, right? Flip it around. Make it tangent of theta is equal to 1 over the square root of 3. Okay, we're getting close. And now that answer is not on the unit circle, but if we rationalize it, change it, we might find this on the unit circle. Okay, so I'm going to rationalize it. Multiply it by square root of 3 over square root of 3, right? And I wind up with tangent of an angle is equal to the square root of 3 over 3. Now that is on the circle. It's fine. In fact, I think it's over there at pi 6. Remember how we put the tangent values on the outside of the circle? So we find square root of 3 over 3 for tangent values. So theta equals pi 6, or in degrees, 30 degrees. Dumb degrees, I know. Now, with a calculator, okay, let me grab my calculator, or a calculator. It's right here. You have my calculator? Oh, good, thank you. So, let's do this one on a calculator. So, cosine of 0.87 in terms of degrees. It's just super easy. There's nothing hard about this one. This is just a matter of pushing buttons. Degree mode, though, okay, got to make sure, because if it says degrees, I'm going to go to degree mode first, right? And then I'm going to go just 0.87. So I want to find the angle, so we do the cosine inverse of 0.87. Okay, you got to do the inverse because we're looking for the angle, right? All right, I can do that. Let's go cosine inverse of 0.87, and I get an answer about 29.5 degrees. So theta is about 29.5 degrees. All right. Now, cosecant is not my calculator. It's not. I've got sine, cosine, tangent. I've got my inverses, but that's finding the angle. Cosecant's not there. You have to have a pretty fancy calculator to get cosecant. There are fancy calculators out there that will do it, but we don't have one. So what do I do? Well, technically, it's a question that says this. Cosecant of some angle equals negative 2.3. I mean, because we're looking for an angle, right? So the question is really cosecant of some angle equals negative 2.3. Now that, we're going to change that because cosecant's not on my calculator, so let's change it to sine. I'm going to go, okay, 1 over sine of my angle is equal to negative 2.3. Flippy floppy, right? We'll do the reciprocal. Let's change that to sine of some angle is 1 over negative 2.3. If we want to find the angle, we have to find the inverse, right? So I'm going to go sine inverse of 1 over negative 2.3, and I can get the answer. Okay. Now, we're going to go back to the original question and say, well, did we have to do all this work? Not if we're smart. There's an easier way to do this one. We should be able to go from here to there real quickly. But let me get the answer first before I go back through that, okay? So sine inverse, sine inverse of 1 divided by negative 2.3, and I get an answer about negative 25.77, or how about theta equals, I'll just round it, negative 25.8, negative 25.8 degrees. Okay. Now let's be smart about this. That's a whole lot of extra work to go from here down to here. Okay, so if we're smart, we take a look at this right here. Okay, and say, wait a minute. I know that cosecant's 1 over sine, right? So what did I do? I made it sine inverse of 1 over that, didn't I? Isn't that faster? This is why it works, but gosh, that's a lot of work for something to say, oh, wait a minute, Steve, isn't it just easier to make it sine inverse of 1 over that? And the answer is yes, okay? Do that instead, right? All right, now, try example 3. We're going to solve for triangle CAT. Well, we don't know an angle. Now, the other day we talked about the steps. Okay, step 1 was always pick an angle, pick an angle. So it's still the same step, but this time we're going to be pick an angle to solve for, okay? Pick an angle to solve for. So, I don't care. Rosa, which angle do you want to find? Angle A or C? Don't, we already know T, Simon. Funny guy. What did you say? A it is. Okay, so once she picks the angle A, then she has forced us, I'm sorry, you forced us to use sine. How come she's forced us to use sine?
Sine's opposite.
Opposite and hypotenuse. So we agree with that? Yeah. So if we set it up, we say, okay, well, sine of angle A is equal to my opposite over my hypotenuse, right? And if I need to find an angle, what button am I going to push? Inverse. Remember that? Always the inverse, okay? So if you need an angle, okay, always remember this. I will say this 3 times just to drive you crazy. If you were lucky enough or unlucky enough to have me in geometry, you know how to do this, don't you? So, when you want to find an angle, push the inverse button. When you need an angle, always push the inverse button. If you have to find an angle, you're going to push the inverse button because...
The inverse button's on with the -1.
Yes, right? Yes. So think about it this way in math. Inverse means the opposite. If you take the sine of an angle, you get a side. The opposite that would be if you want to find a side, to take the sine inverse of the side gives you the angle. Okay, so let's do that. Let's go sine inverse. So I'm going to rewrite this as sine inverse of 8/17. Because it's a triangle, we have to do it in terms of degrees, right? Because it's a triangle, we're going to do it in terms of degrees. So I'm going to check my mode, because I think I had it in radian mode. Nope, degree mode. Okay, that's good. So I'm just going to go simply sine inverse, which is the -1, Simon totally right, 8 divided by 17, and we get an answer of about, 28.1 degrees. So angle A is about 28.1 degrees, okay? Okay, if that's angle A, again, let's be smart. Some kids would say, okay, to find this other angle, I can go, 180 minus this and this. But, these two angles have to always add up to 90, right? Let's be smart about this. There's S90, so I'm just going to, okay, angle B, or angle C is just going to be 90 minus my 28.1, because those two angles have to always add up to 90. So 90 minus my 28.1, and I get an answer about 61.9. Okay. And then finally, two ways to find little c. You could use right triangle trig. We could set up, either tangent or sine, or I can just use Pythagoras Theorem. How about Pythagoras Theorem, huh? So I'm going to go, okay, 8 squared plus little c squared equals 17 squared, right? Little c squared equals, 17 squared minus 8 squared. Yeah, it is a special triangle. I like the nice ones. I try and pick the easy ones. 17 squared minus 8 squared. And so I'm going to take the square root of 225, which should be 15, okay? How's that? Okay. All right, everybody good? Should we turn the page? Okay. All right. So, example 4. Mr. Daly, how are you? Good. We're doing a little right triangle trig. Thank you, guys. Thank you, Mr. Daly. Unplug those boys. So, do you need me real quick? Okay. Cool. Hang out with us. So, a 40-foot ladder rests against a building where the base of the ladder is 6 feet from the base of the building. Find the angle between the top of the ladder and the side of the building. Let's draw a picture. Okay? Let's draw a picture. So, here's my building. I'll make it skinny building because, it's like Wayside School. Okay? Yeah, somebody got that, huh? Have you ever been to Wayside School? You guys remember Wayside School?
Yeah, I know what you're talking about.
Looks just like... Okay, so a 40-foot ladder rests against a building. So let's put my ladder. Here's my ladder, right? And it's a 40-foot ladder. Okay? The base of the ladder is 6 feet from the building. Find the angle between the top of the ladder and the building. That'd be right there, theta, okay? Right? We're assuming it is right triangle. So, opposite, hypotenuse. Which one are we going to use? Opposite hypotenuse, which one am I going to use? Sine. Sine of theta equals 6 over 40, right?
Don't you need an angle though?
We do. Let's find the angle.
So sine inverse.
Sine inverse of 6 over 40 will give you my angle. Yeah. We do need an angle, Simon. You're totally right.
Yay.
So we're going to get it, aren't we? So we're going to go sine inverse 6 out of 40. And we get about 8.6 degrees. That's pretty small, but it's a tall ladder, right? 8.6 degrees. That is pretty steep. I mean, think of that. So that's one of those ladders where you better not lean back too much.
Wait, so that's...
Seriously, that's steep, right? That's where if you go like this, you're going back, huh?
I have a friend on the other side.
Right, yeah, I have a friend right here hanging on that ladder, right? So it doesn't go over.
Duct tape the top of the ladder to the wall.
Okay, example 5. So this is a little bit like what Sam did on the warm-up. Let's see how it works, okay? So let's draw a triangle. So if I draw a triangle, right, and I know that the sine, here's my angle, is going to be the opposite over the hypotenuse, right? Hopefully everybody knows what that side is. I could do Pythagoras Theorem, but hopefully everybody knows what that side is. You ever heard of a 3, 4, 5 right triangle, right? 3, 4, 5. Now if you're not sure, you could go 3 squared plus b squared equals 5 squared, and you'll get 4. You really will. Okay, now if we need the cosine, it's just going to be 4 over 5, right? Because cosine is the adjacent over the hypotenuse, right? Adjacent the hypotenuse, so it's 4 over 5.
Wait, where does the sine inverse come into play on that one?
It came into play, in fact, great question. So we know that sine of an angle is equal to the opposite over the hypotenuse. So the sine inverse means there is an angle, okay? Because that sine inverse means there's an angle that has an opposite over hypotenuse in a triangle, okay, of 3 over 5, right? So this allowed me to create my triangle. Sine inverse means there's an angle that has an opposite over hypotenuse, okay? Of 3 over 5. And then by, Pythagoras Theorem, we got the 4. And then we said, let's take the cosine of that angle, which would just be the adjacent over the hypotenuse, which is 4 over 5.
Okay, yeah, that makes sense.
Now 6 is a little bit different because you got to do things in terms of x, okay? So, Nikolai, let's do the same thing. There's an angle, okay? There's an angle, because inverse means there's an angle. There's an angle that has an adjacent of x and a hypotenuse of 1. Okay, this one's a little harder to do. So we have an adjacent of x and we have a hypotenuse 1, but we don't know the opposite side. So we're going to use Pythagoras Theorem. Nika's wide awake, of course. We're going to use a Pythagoras Theorem to find this opposite side. So I'm going to go, I'm going to go x squared plus b squared equals 1 squared. I'm just using Pythagoras Theorem. Let's call this b for right now, okay? X squared plus b squared equals c squared, right? So I'm going to have b squared is equal to 1 minus x squared. All I did is I brought the x over the other side because I need to solve for b. I need to get this side right here, okay? Square root. So b, or that other side, is equal to the square root of 1 minus x squared. So let's put that over here. Square root of a 1 minus x squared, okay? This is a harder one. If it's in terms of x, I knew cosine was adjacent over hypotenuse. So I had to make it x over 1. I needed a value here, so I made it over 1, okay? So I had my adjacent and my hypotenuse, but I don't know this opposite side. So again, I used Pythagoras Theorem, but I used it with x. So I went x squared plus b squared equals 1 squared. And I solved for b, which was the square root of 1 minus x squared. So that is this other side. So now let's find the sine. So the sine of this angle, sine of theta, is equal to the opposite over the hypotenuse. So it would just be the square root of 1 minus x squared over 1. And I don't really need the 1. And that is the value of sine. Now, you're going to say to yourself, where am I ever going to use this? Okay? Again, this is a good setup for calculus. In calculus, you will be doing problems like this. And then you'll do more with this in calculus, all right? Doesn't seem like you've done much. More practical to do problems like this. But this is a problem in terms of x, okay? All right, so here's our homework. I want you to, are you listening, Luke? I want you to write or draw the picture, show the work, okay?